So let's do this test for goodness of fit. This question says, the table below lists the frequency of wins for different post positions in a horse race. So if you've ever watched horse racing, you know that they line the horses up in different positions in little pens, and each of those positions has a number, and that is the post position for that horse for that race. A post position of 1 is closest to the inside rail, so that horse has the shortest distance to run. Because the number of horses varies from year to year, only the first 10 post positions are included. Use a 0.05 significance level to test the claim that the likelihood of winning is the same for the different post positions. Based on the results, should bettors consider the post position of a horse race? So is the place the horse is posted going to influence how likely it is that they will win the race? And if you are going to bet on that race, should you then take that into consideration when you make your bet? So this is a goodness of fit test because the claim we're looking at here is that the likelihood of winning is the same for the different post positions. And what we have here for the data is the frequency or the total number of wins that have occurred for all the different post positions over a period of time where we collected this data. This is a goodness of fit test. In a goodness of fit test, the null hypothesis, H0, is always that the distribution is going to agree with whatever the claim says. So here, the claim says that the likelihood of winning is the same for the different positions. If it's the same, then that means the number of wins would have been the same or equal across all the different categories. So we're going to choose that the null hypothesis is wins occur with equal frequency in the different post positions. So the alternative hypothesis is the opposite. The alternative hypothesis would say that not all of the post positions are going to have the same frequency of wins. At least one of them is going to be different than the others. So you have to be careful with the wording here a little bit because they change it ever so slightly, but let's see. It looks like it's going to be this one. At least one post position has a different frequency of wins than the others. So now we want to calculate the test statistic for this goodness of fit test. To perform the goodness of fit test, we're going to open this data in StatCrunch. We're going to go to click the little blue box in the upper corner of the data, and we choose Open in StatCrunch. When the data opens, to perform a goodness of fit test, we are going to choose Stat, Goodness of Fit, and chi-square test. So the first thing that they are asking us is what column of data are the observed values in, meaning the data that we actually collected. Which column of data was that in? So let's move this over so we can see. So column 2 that is labeled as wins, that was the data that we collected. That is the total number of observed wins for each of the different post positions. So we'll choose the wins column for the observed data. Next comes expected. What is the expected frequency, the frequency that came from our claim? Well, remember in this problem, the claim was that all the wins would be equal in the different positions. So we're going to select the cell that says all cells in equal proportion. That's all we need to do. So we're going to go ahead and click compute. And now we will have this information. The test statistic that we were asked for is right here. Chi-square is the test statistic. So I'm going to highlight and copy that number and bring it back over here and paste it. And this one said to round to 3 decimal places. So 1, 2, 3. We look at the 3 right here. The number after the 3 is an 8, which means we should round the 3 up to a 4. So that is the test statistic for this problem. Next, we want the p-value. Again, that was also provided in StatCrunch right here, p-value. So we can go ahead and copy this number and paste it into my MATLAB. This one wants us to round to 4 decimal places, and it's already to 4 decimal places, so we don't need to make any adjustment there. So finally, we are on to our conclusion. How do we make the conclusion? The way we always make our conclusions for a hypothesis test is we are going to compare the p-value to the significance level. Our p-value in this problem was 0.1395 and the significance level was 0.05. So the question is, which one of those numbers is bigger? In this case, the p-value is bigger than the significance level. So what we do when the p-value is bigger than the significance level is we fail to reject H0. We fail to reject the null hypothesis. So I already know that letter B and letter C here are not going to be the answer because I should be failing to reject the null hypothesis. So the next question is, what does that mean regarding my claim? Let's look again at what the null and alternative hypotheses said. The null hypothesis said winds occur with equal frequency in the different positions. And remember that for this problem, that was the claim, right? They told us up here, test the claim that the likelihood of winning is the same for the different positions. So in a goodness of fit test, your claim will actually be in the null hypothesis. That wasn't always the case with previous tests we did, but it is the case for a goodness of fit. So if this is the claim here in the null hypothesis and I am not rejecting that claim, right? I failed to reject it. I did not reject it. In other words, I kind of accepted it. Then that means I have supported my claim. There are always two hypotheses. One of them I will reject and the other I will accept in the most simple terms. So H0 here was the claim. I did not reject it. In other words, I accept it. So since that was my claim and I accepted it, I have supported my claim. The two options down here say there is significant evidence to warrant rejection of the claim, and this one says there is insufficient evidence to warrant rejection of the claim. So again, H0 was the claim and I did not reject it, so I had insufficient evidence to warrant rejection of the claim that the likelihood of winning is the same for the different post positions. As usual, the wording, the technical wording at the conclusion of a hypothesis test can get a little tricky and there can be a lot of double negatives you have to weed through, but if you take your time and really read it carefully and think about what was in the H0 and in the H1, it will start to make sense as you do more and more. So this answer should be D.